Hello, hi everyone. Welcome to the Student Brand. Today we are discussing about electricity chapter. So you can see the previous live class. So in the previous class, I explained about light reflection. Sorry, electricity. Electricity we are going to discuss. So if you see the live class morning at 11 a.m. So I took that time. So I explained about electricity topic until difference between resistance and resistivity. So difference between resistance and resistivity, until that one we discuss. Hi sir, hello sir. Got results today. How much you got on Earth? Uh, Sonish, hi. How much you got? So I hope you get good marks according to me. I got results today. Very nice. Okay. So let's come to the class, everybody. Now we are going to discuss about very famous topic, very good topic, excellent topic. Very seriously, we need to practice on this topic, like that type of topic. Because of you, sir. 37 in Punjab, 36 in. Oh, very nice. So maths, I got a less stick checking. Okay, very good. Keep it up. Good job. So try. See, you can watch the live class, whatever I'm uploading. So today also I uploaded resistance. Okay, so until resistance, the difference between resistance and resistivity, until that one I explained. So today we will do. Today we'll discuss about resistors are in series, resistors are in parallel, resistors are in series, resistors are in parallel, resistors are in series, resistors are in parallel, and related to that we'll do problems. So if you have any doubts, sir, how can I keep it up? I have just to do more hard work on maths. So keep it up in the sense you must no increase the marks. Okay, so up, keep it up means still you have to do more. That is the reason. That is the meaning of this statement. Okay, nice. So do hard work. Definitely will do it. See, it's now it is starting only, still we have more time. So still we have more time to do the work. Okay. So right now we are in initial stage. So no problem. Still we can do it. So believe in our process. Believe in our hard work. So change the methods and improve our preparation levels. Okay. And try more number of problems and concepts, then we can do it great and better and good. Okay, so now we are going to discuss. Yeah, thank you so much. I only marks because marks because of you in physics. Oh, very good job, great, well done. So I hoping you all the best for the future purpose. Definitely will improve our subject and marks too. Thank you so much, sir. Well done. Great. So come to the next one. So today we are going to discuss about resistors are in series, resistors are in parallel, resistors are in series, resistors are in parallel. Okay. So in this no topic, so especially in this problem, in this chapter, resistors are in series, resistors are in parallel. Based on that one, many questions will come. Many questions, especially so problems. Resistors are in series, resistors are in series, are in series, are in series, and resistors are in parallel. Resistors are in series. How can we identify resistors are in series? So yes, I am only telling about physics after joining my marks of my bio and chemistry. Then, sir, it's simple. I got 32 only. So one MC got wrong. Okay, so remaining everything you did correct. Okay, nice, nice. So please, can you solve the question I got in exam? I don't know why my teacher marks. Okay, so fine. Definitely will do it. So meanwhile, so send, I will do it. So if you are taking resistors are series, so I'm taking here, so one resistor, another resistor. So like that, three resistors I'm considering. Three resistors. Okay. Three resistors. Resistor number one. This resistor number one. Resistor. And one more resistor. And another resistor. So here you need to understand one thing. Here you need to understand one thing. Here you need to understand one thing. So these three resistors, 1, 2, 3. So this is R1, R1 and R2 and R3, R1, R2, R3. So if you are joining like this, so my method of explanation of resistors are in series is simple. So I can say this is starting and ending, starting and ending, starting and ending. In that way, so ending point of the first resistor to starting point of the second, ending point of the second resistor to starting of the third one. So if you connect in that way, so those resistors are connected in series combination. Those resistors are connected in series combination. So and the current, the current, the current, the current, the current in the current in the circuit throughout circuit will be same. Current in the circuit throughout the circuit current is same. Then the type of combination, the type of combination is called series combination. So if I'm taking the battery here, two or more cells connected together is called battery. I'm taking here open switch. Oh, sorry, open switch. If you are placing the dot, it is a closed switch. Once again, you can see here. Here I'm taking positive and negative. Current is passing like this. Current is passing like this. R1, R2, R3, R1, R2, R3, R1, R2, R3, R1, R2, R3. All three resistors are connected in series combination. All three resistors are connected in series combination. All resistors are connected in series combination. So potential difference will be there. Potential difference will be there. So across R1, V1 is there. Across R1, V1 is there. Across R1, V1 is the voltmeter. Across R2, V2 is the voltmeter. Across R1, V1. Across R2, V2. Across R3, V3. So these are the voltmeters connected across R1, R2, R3. So why we are connecting different voltmeters across different resistance? Because 30 centimeter, right? 30 centimeter. Sir, does the change of ammeter depend on the charge of battery or circuit? No, ma Anahat. So actually, so your answer is this one is the concave mirror. Concave mirror. So normally, so light rays are coming and meeting means so light rays are coming parallelly. Those light rays are meeting at one point means this is a 15. So where we have to place the mirror to get same size of the object or same size are equal. So you said equal in to the size. So if you are placing the object at 30 centimeter, so object at 30 centimeter, so image also will form at same only, right? Image also will form same. Then we will get equal. From here to 15, from here to 15, from the where image is forming, where image is forming. So the question is from the image is 15, from the pole is 30, from the pole is 30 because this radius of curvature to the spherical mirror. Hi Srikar, how are you? Welcome to the class. So every day 9 o'clock I'm taking class. Srikar, you can join. 30 is 30 from the mirror. 30 from the mirror is correct. 30 from the mirror is correct. Not 15. 15 is at focus. That's the focus. 15 is the focus. They are like the soul. The first case only. In mirror's case, first case is only that one. That is the answer. First case you see, light rays are coming from an infinity. After reflection, it meet at focus. The distance between focus to pole is called 15. But so they asked about where you will get equal size of the object. So object must be placed. So 30 centimeter from the mirror. Answer is 30. 30 centimeter from the mirror. Correct. 30 is the correct. Not 15 is wrong one. Okay, so 15 is the focal length. So equal size, if you want to get equal size of the object, means compulsory you have to place the mirror at center of curvature. Then image and object both will be equal, even if you're placing the object also. But my physics teacher says it's 15 in front of the mirror. In front of the mirror, 15. Question. Can you, if you send the question, it is good. But sentence and formation from the mirror or from the focus. So I said no, from the focus or from the concave mirror. See, equal and see, there is a clear discussion from the focus. If they mention from the focus, I said two questions, two answers I said. Point number 1, from the focus 15. Point number 2, so you mention from the mirror in the sense from the pole. From the pole equal and same size, you will get only center of curvature case. That is the focal length, already you said 15. Second case is 30. So 30. Okay. If they say from the focus 15, so question must be very clear. If the question is clear, from the focus is 15, from the mirror is 30. From the mirror is 30. So you have to read the question twice. See, physics, you must read the question again and again. So again and again until you get, instead of marking wrong answer, better you pass the question. So normally if anyone asks, so if you tell immediately answer, maybe it is correct or not. Once you stop and think about the question, you may get the correct answer. So we have to pass before thinking or before answering any question. You have to think about the question. If in physics, you have to read the question again and again. Number of times, if you read all, you will get it. Shivani, what is your doubt, Shivani? 100%. See, in convex mirror, so always virtual erect and diminished image will form. Virtual erect and diminished image will form. Even we can see full view of the Taj Mahal. If you place in front of convex mirror, we can see full view of the Taj Mahal. Full view of the Taj Mahal. Okay, in convex mirror, see, because field is more. For convex mirror, field is more. That is the reason. Sir, the positive terminal of ammeter should always be placed with which terminal of the battery? See, ammeter will allow the current in only one direction, that is positive direction. Ammeter should allow the current, right? Ammeter should allow the current. In which direction it will allow? Through positive direction. So ammeter positive, I will tell. So yes, very good question, Shivani. Angle of reflection is 35. The angle of incidence will be. So here I am taking. So this this is 35. This is 35. So 90 minus 35. This total is 90. Perpendicular angle. This is 90. 90 minus 35. You only tell. 55. I hope. Yes, 55. So 5 you add 40, 55. So 55. So you can, if you add also 40, 90. Answer is 55. Angle of, you say angle of incident. Angle of incident is 35. See, angle of reflection. Angle of incident equal to angle of reflection, right? So I am talking about this one. I am talking about the angle of glancing angle of incident. So angle of reflection, angle of incident equal to angle of reflection. No, without any, without second thought, Directly you can write 35 itself, because angle of incident equal to angle of reflection. It is not the law that angle of incident is equal to angle of reflection. Angle of incident equal to angle of reflection only. Angle of incident equal to angle of reflection only, right? So that's why, so angle of incident to angle of reflection, 35 equal to 35. No doubt, Allah. Why you are thinking again? These are the basics, fundamentals, fundamental questions. That's why already that day I said, right, these questions will come. So angle of incident equal laws are related to laws of reflection. I explained very clearly. Many times I stressed that question. Many times I stressed this question will come related to this concept will come. This concept is very, very important. Especially laws of reflection, very, very important. So definition important, statement important. So everything is important. You have to work out. Okay, practicing diagram, angle of incident equal to angle of reflection related to that concept. Definitely one question will come. Shivani, you said you didn't ask. Sir, I'm struggling at electricity. My exam is on Tuesday. Today? Today, Thursday. What is the date today? I hope Thursday. Tuesday means next week. Oh, sorry, Friday. Today, Friday. Okay, so Friday. Okay, so we are working on. See, Shivani, I will tell one thing. So Friday, very good. I will tell one thing. So you watch my videos. Okay, there is a crystal clear topics I explained many times. I explained a doctor has prescribed a lens plus 2.5D. What is the nature of the lens? It can be converging or divergent depending on the position of the object from the lens. Definitely convex lens converging. Why? So in the textbook, so I don't have textbook. I'm seeing you only. In the textbook at the last page, from the fourth line, from the top to fourth line. So before starting the question and answers, fourth line. So power of lens is positive for convex. Power of lens is negative for concave. So I'll show the proof. I don't have textbook right now. Those who have textbook, you can check right now. Yes, I'll check. Okay, yes, it is it. So here, see, I'll show you that. So where it is. So power of lens is positive for convex lens. Power of lens is negative for concave lens. Okay, so if you read that one, automatically you'll get it. So here, see. Yes, see this the before starting the questions. Here they mentioned, right, before starting the questions. So here you see 1, 2, 3, 4. So this is diopter. So power of convex lens is positive. Exactly fourth line. Exactly fourth line. You can check once, no problem. You can check in the textbook. Exactly fourth line. Power of convex lens is positive and that of concave lens is negative. Exactly 1, 2, 3, 4. Fourth line. Fourth line. Power of lens is positive for convex. Power of lens is negative for concave lens. Okay. So that's enough. So by seeing the sign, you must remember, you have to think about it. So power of lens is positive for convex, power of lens is negative for concave. So keep in mind, that's enough. Convex lens is converging lens. That day I said very, very important related to names, other names. Convex lens, converging lens, concave lens, diverging lens. Related to this question, related to this point, one question will come, I said. Very, very important question, I said. So that's enough. So one question came. And but it's not saying converging, it is diverging. It is saying it can be converging, cannot be diverging, depends on the position of the object lens. This statement is right or wrong. Actually, at the last case, we are extending the light rays. We are extending the light rays. We are extending the light rays. So position, at the last position, we are extending the light rays, right? So diverging, so we are extending the light rays, those image will form. But still, convex lens we are considering as a converging lens. Okay. Shivani, so yes, you say you asked one question, right? Okay, fine. So attend regularly. So no, so please tell me the statement right on. But it is not saying. It is not saying converging. What is your question? but it is not saying converging or diverging. It is saying it can be converging, can be diverging depending on the position of the object from the lens. If this statement is right or wrong. Hi Tanishka. Actually, it is a converging lens, ma. It is a converging lens only. Whenever the light rays are falls on it, it will converge and make it falls at retina only. It is converging only, right? Light rays, if it is diverging, means whenever the light rays are falls on it, it should diverge. So light rays are not diverging, right? Not diverging. Always it is a converging light rays. So it's a converging lens only. Depending on its position. Okay. Yes, ma. So you can see, you can check once. So converging only. So as of it is, according to the position also, it is converging only. Light rays are converging. Sir, now started. Yeah, now 9 o'clock it is started. 9 o'clock it is started. Sharp 9 o'clock I'm starting nowadays because students are joining. So Tanishka, you can check once my live classes. So live classes you can check already. I have uploaded morning also. I explained until resistance depends difference between resistance and resistivity. Until that I explained. So right from starting, you can watch. Now I'm explaining resistors are in series and resistors are in parallel. So after this one, still I will explain. Okay. So that's enough. That is about the. Mm, Still, anybody have questions? Okay, Sivani. So you asked right. So you can watch the live classes and attend the live classes. Still, anyway, I'm explaining. So derivation is very, very important. Derivation is very, very important. Whatever I'm explaining, this derivation is very important. And I am explaining right from starting onwards. So this chapter I'm explaining. Okay, right from whenever I started the classes. So live classes from that time onwards, I'm continuously explaining light chapter. So light, no, sorry, electricity chapter. Electric light chapter I'm explaining, electricity chapter also I'm explaining. So electricity chapter, see, complete detailed view I'm giving, see, including problems, including circuit problems also I explain. Once check the circuit problems also. Still so many no, so many series I'm going to continue because related to electricity we need to work out. So even before exams also you can watch these videos daily. If you watch also, if you are joining and practicing also, it's very good. So take a notebook, everyone take a notebook and practice along with me. Okay. Hi sir. Who is that here? Someone said hi. Hi. Anubhav, right? Affection. Anubhav, right? Okay. Okay, fine. So still we need to work out. So okay. So we'll start electricity topic. So we need to work out. So still problems are there. Okay. Here, so resistors are in series, resistors are in parallel, resistors are in series, and resistors are in series. Now we are discussing resistors are in series. Haha, okay, fine. I stopped just now only. So I'm getting calls. That's why it is happening like that. Okay, so here you can see, you can observe here. So R1, R2, R3, R1, R2, R3, R1, R2, R3. So that's enough. Okay, okay. Fine. So now I am considering here R1. So RS equal to R1. Oh, so we can't go for final, right? So we have to start from starting. So now we are going with the one more. So we can check now. We can check now. We can check now. So R1, R2, R3, R1, R2, R3, R1, R2, R3. Okay. So resistor R1 and R2 and R3, R1, R2, R3, R1, R2, R3. Now we can go for one more one. From Ohm's law. From Ohm's law, V equal to IR. From Ohm's law, V equal to IR. From Ohm's law, V equal to IR. V equal to IR. So the potential difference, so Vs, so the potential difference, see here it will, so from here potential difference will be there. The potential difference from the battery, so whatever the potential difference in the series combination equal to V1 plus V2 plus V3, V1 plus V2 plus V3. So Vs equal to V1 plus V2 plus V3. So now I am considering, so Vs equal to, here you can take, so from Ohm's law, V equal to IR. From Ohm's law, V equal to IR. So now I am considering IRS equal to IR1 plus IR2 plus IR3. IRS equal to IR1 plus IR2 plus IR3. IR1 equal to IRS equal to IR1 plus IR2 plus IR3. I we can take common. So R1 plus R2 plus, because whatever the current is flowing from here, so through entire all resistors, current is same. Through entire all resistors, current is same. That's why I'm taking. So R equal to, so we can consider IS equal to I1 equal to I2 equal to I3 equal to I3 equal to I. So from this, so we can get cancel. So RS equal to R1 plus R2 R3. R1 equal to RS equal to R1 plus R2 plus R3. Sometimes they will ask about so derive the expression for resistors are in series. Derive the expression for resistors are in series. Resistors are in series. Tanishka, you asked about the chapter, so that's why I'm explaining. So listen, try to write in notebook. So if you maintain notes, so automatically it will be good. So many times I explain the same derivation. Try to write in one notebook. Okay, so it will be good. So even you can check in my previous live class also, same explanation will be there. So but the explanation may be different scenario, but same content, whatever I'm writing, same thing will be there, because so we can't escape the main concept is same. So here, so current is passing from battery to the resistors. Okay, so from Ohm's law, V equal to IR. So potential difference from the battery, Vs equal to V1 plus V2 plus V3, that is nothing but Is equal to I1 equal to I2 equal to I. So here you can see, IS. So whatever the potential difference from the battery we are getting, that is IRS equal to IR1 plus IR2 plus IR3. So II get cancelled. So the remaining values are R1, RS equal to R1 plus R2 plus R3. So very important. So diagram is important, and here also this is very important. In series combination, which physical quantity is constant? 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 So the physical quantity constant in series combination is current. So current is the physical quantity. Current is the physical quantity. Current is the physical quantity which is constant in series combination. Which is constant in series combination. Which is constant in series combination. So very important concept. So, and one more thing, potential difference. Potential difference, if you are considering potential difference, okay. So potential difference. So okay, may until now, until this time, just work out on it. Just give me 2 minutes time. Just meanwhile write down, students. Okay, so I hope it is clear now. Is it audible? If any concern is there, just let me know. Is it audible to you all? Audible and visible? Those who are there in live class, let me know. Is it audible and visible to you all? Okay, so I hope it is clear. I hope it is clear to you all. Okay, so now that's enough. Resistors are in series. Resistors are in series completed. Now we will discuss about resistors are in parallel combination. Resistors are in parallel combination. Right. Now, shall we go to the right? Yes. So resistors are in parallel combination. So resistors are in parallel combination. Sir, positive terminal of ammeter is always connected to positive terminal of battery. Correct. What is SI unit full form? Standard International. System of International. Sorry. System of International. International system also we can say. Right? So completed or not? So taking now, I'm considering resistors are in parallel combination. Resistors are in parallel combination. Resistors are in parallel combination. So I'm considering here. So now here, if you are taking this is a starting point of the one resistor, starting point. This is starting point. If you are new to the channel, so do like, share, and subscribe to Student the Brand. So you'll get more content related to CBSE Grade-10 physics coming. So we planned so many points. So practice session, preparation session, and doubt clarification session. And see, if you are not getting clarifying your doubts, or if you want to discuss more, okay, over. So I'm starting with 11 o'clock. Sorry, 10 p.m. 10 p.m. So 10 p.m. So every day every day at 10 p.m. Every day at 10 p.m. Talk with Siva sir. So talk with Siva sir. Siva sir. So like that I'm starting. So you can join so to that class in YouTube only live class. So you can ask, you can discuss only purely open discussion like exams, so how to plan, how to prepare notebooks, how to write notebooks, how to follow general questions, general doubts, general preparation methods, and maintaining notes and planning like a timetable like that. So if you have any concerns related to subject, which topic we have to start, where we have to start, how to prepare, okay, where we need to focus, what type of questions are important. So these type of questions, maybe we may not know because I'm explaining the content as well as going with the and no question whatever your comment, so it may take time sometimes, so we will not cover the concept, so I'll focus on the concept so during the class. So that time you can join, so completely we will talk general talk, so like like what I said, essay unit and preparation methods, and which topic is important, which topics need to focus, which topic we need to practice, like everything. So you can join at that time, so we will discuss more points. Okay, so I'm taking so positive terminal. So here I'm taking this one R1 and R2 and R3, R1, R2, R3. So I'm taking a potential difference. So voltmeter here, voltmeter. So I'm connecting voltmeter here. Talk with Siva sir. Every day at 10 p.m. every day, like how I'm taking 9 o'clock class. So every day at 10 p.m. So after immediately completion of this class, so we'll be having talk. Yesterday also it is there. So you can check once. Yesterday, one class is there. So talk with Siva sir like that. So that also there. So you can check once. So if you are interested, you can join to that time, and you can just discuss with the general topics and how to practice, how to prepare like that. So sometimes you may not know discuss openly. So at least you can comment. So that time it is possible. I'll answer. So only completely through two comments. I'll answer pure comments. Only purely for comments only I'll answer here because I'm working on the concept, right? So we may not get time to answer to your comments. So definitely you can join to that time. Only for comments only I'm conducting. So you can your doubts, your clarification, your preparation. If you have any subject preparation lagging, how to plan, how to prepare, where we need to concentrate, how we need to concentrate. So which time is the best time for preparing? Which books are preferable to prepare? How to prepare? Which books we need to select? How we have to prepare from starting onwards, and exam papers, preparation, and like that. All the things you can talk with me. So at that time, right? I hope already completed. Only 15 minutes are left. So we'll discuss on uh, resistors are in parallel combination. Resistors are in parallel combination. Current is passing. Positive terminal, negative terminal, positive terminal, negative terminal. Current is passing. So here is the key. So battery I'm taking. This is a battery. Current is passing. R1, R2, R3, R1, R2, R3, R1, R2, R3, R1, R2, R3. So three resistors are connected in parallel combination. So from Ohm's law, V equal to IR. From Ohm's law, V equal to IR, I equal to V by R. I equal to V by R. From Ohm's law, V equal to IR, I equal to V by R. I equal to V by R. So IP equal to here current. So current, see when the current is passing I. So here it is dividing I1, I2 and I3. I1, I2, I3. I1, I2, I3. I1, I2, I3. I1, I2, I3. So current is passing through it. Current is passing through it. So current is dividing into three parts. I1, I2, I3. I1, I2, I3. Okay. So I1, I2, I3. So into three parts it is okay divided into three parts divided the total current, so that I current in parallel combination from whatever the current is passing from here, the total current in parallel combination equal to I1 plus I2 plus I3. And here, and one more thing, so the potential difference across R1, R2, R3, the potential difference across R1, R2, R3, R1, R2, R3, R1, R2, R3, R1, R2, R3, the potential difference across R1, R2, R3, so is same. The potential difference across R1, R2, R3 is same. So that's why, so we are considering Vp equal to V1 equal to V2 equal to V3. So Vp equal to V1 equal to V2 equal to V3. V1 equal to V1 equal to V2, 3 equal to V3 equal to V. So V I'm considering. So from Ohm's law, IP equal to I1 plus I2 plus I3. IP equal to I1 plus I2 plus I3. So V by Rp equal to V by R1 plus V by R2 plus V by R3. So here you can see V by Rp equal to V by R1 plus V by R2 plus V by R3. So shall we take V common? Shall we take V common? Ayush, how are you? Come on, welcome to the class. So welcome to the student the brand. I am Siva sir, I'll teach physics. Welcome to the class. So what happened? Nowadays you are not entering. Yesterday also you didn't join, I hope. Join to the class, Ayush. Say hi at least to me every day. Hi. So VV get cancelled. So 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. So that is the answer. So 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. So 1 by R3. So this is the answer. I hope it is very clear to you all. So once again check once here. So R1, R2, R3, 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 R1, R2, R3. All three resistors are connected in parallel combination. All three resistors are connected in parallel combination. So current in, see which physical quantity is constant in parallel combination. That is very, very important. 1 mark question. So this is 1 mark. So 1 mark question. So which physical quantity is constant in a parallel combination is potential difference. Okay, very good. Keep it up. So nice. So you joined to the class. That is, I am very happy. I am very glad. Okay, done. So Vp equal to V1 equal to V2 equal to V3. So that is V. So that is, this is 1 mark. The potential difference is constant in a parallel combination. Potential difference is constant in parallel combination. Potential difference is physical quantity. Which physical quantity is constant in parallel combination? Which physical quantity is constant in parallel combination? Like that, they will ask which physical quantity is constant in parallel combination. Because summer vacation is over. Harsh. Hey, hi Harsh. How are you? What is your name? Harsha or any other name? So the title name is Harsh. What is your name? Hi. Welcome to the class, student the brand. So you join. Welcome. So if you like this video, please do like, share, and subscribe to Student the brand. So you can inform to your friends, ask them to join. Hey Harsh, very good. So nice. Myself, I am Siva sir. So welcome to the class. So if you like this video, if you like this content, please do like, share, and subscribe. And if you are liking this content, you can inform to your friends, ask them to join every day at 9 p.m. Definitely physics class will be there. So spread one word regarding the physics class. So let everyone know, let everyone learn, so let everyone grow. Right? Education for all. Okay, done. Come to the points. IP equal to I1 plus I2 plus I3. So I am considering IP equal to I1 plus I2 plus I3. So the which physical quantity is constant? Which physical quantity is constant in parallel combination? Which physical quantity is constant in parallel combination? Which physical quantity is constant in parallel combination? Which physical quantity is constant in combination? Potential difference. Potential difference. Okay, so potential difference is constant in parallel combination. That is a physical quantity. So they will ask in this manner, which physical quantity is constant in parallel combination? Potential difference, right? So by using Ohm's law, V equal to I or I equal to V. So IP equal to I1 plus I2 plus I3. The current is passing here. So among the three resistors, the current will be divided into three parts: R1, R2, R3. So I1, I2, I3, I1, I2, I3. So IP equal to I1 plus I2 plus I3. So V by RP equal to V by R1 plus V by R2 plus V by R3 plus V, so on so on. So how many resistors? So how many resistors you connect depends on that. So the formula will be there. So here V is common. As I said, physical quantity is constant. V is common. I am taking V common. So V get cancelled. 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. So here you can see 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. So this is about resistors are connected in parallel combination. Resistors are connected in parallel combination. The formula for resistors are connected in parallel combination. So next topic is extraordinary topics. So very important topic. Each and every line is a diamond. Each and every line is a diamond. So okay, so each and every point is very important, highly important. Okay, so from this topic, if you are preparing, so without knowing that line, so somewhere you'll miss the points, because for exam definitely the topics will come, that line will come. So based on that one, problems will come. Next, whatever I'm going to explain, the topic is extraordinary topic. Extraordinary topic. Really, it's a marvelous topic. Okay. So very valuable topic, very important topic, very expensive topic also. Very expensive topic. So how the hero entry, when the movie starts, how we will give importance, how we will give entry, BGM, sound system, and background, like okay, so everyone will waiting for the hero, right? Hero entry, like the same here in our topic electricity. So whatever I am explaining, that is like a hero of the movie, hero of the class. So that is facing too much problem in numericals of light. Any tips? Facing too much problem in numericals light tips. So here you can see, this is, I hope you can see, every day at 10 p.m. talk with Siva sir. Only 7 minutes are left. You can join to this class. Definitely I will give. See, you can watch. Okay, I will tell one tip, on one tip only I will tell. You can do extraordinary numericals, like especially light chapter. Especially light chapter. I'm telling to you only, Harsh. So you watch today itself my light reflection diffraction recent live classes. So there I explained one technique. Okay, in that 3 points are there. So in only one technique, 3 points. So those 3 points, if you follow, you can do any problem. Like that I explained. Once see the live class. Once see my live class. So recently live class. Go to live. Click on live. So you can see that name. So I placed very clearly. So you can see light reflection and refraction. Recent uploaded videos. So yesterday or before that day. So in that videos I explained very clearly how to draw the diagram, light chapter diagrams, and how to do the problems also I explained. Once check the videos before starting the class. Still, if you have any doubts, we will discuss in the talk with Siva sir class. Because so maybe concept may lose, because I given so extraordinary introduction regarding the next concept. So let me finish that one, then I will come to you. Okay, Harsh? So we know potential difference equal to work done by, so the rate of so work done to bring unit positive charge from one point to another point. So work equal to V into Q. So this is the potential difference formula. So don't think some other formula. This is a potential difference formula. V equal to W by Q, W equal to VQ. So we are taking power. So what is the power? Rate of doing work. That is nothing but VQ by T. So that is nothing but V into Q by T. So V into Q by T. That is nothing but V into I. So I equal to Q by T, right? Rate of flow of charge. Rate of flow of charge. Everybody listen. Rate of flow of charge is called electric current. So P equal to VI. So energy is given to the conductor. Is equal to P into T. So P into T, P into T, P into T. So V I into T. So we know Ohm's law. We know Ohm's law. We know Ohm's law. Ohm's law equal to IR. V equal to IR. V equal to IR. Whatever the energy is given to the conductor, that will become heat. That will become heat. That will become heat. That will become heat. IR into I into T. IR into I into T. So H equal to I square RT. 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 Now you see the introduction what I given. Is it relevant to this content? Is this relevant to content or yes or no? Yes or no? Tell me. Extraordinary point. Extra each and every line like a diamond. Each and every line is a diamond. Each and every line is a diamond. I equal to Q by T, V equal to W by Q, W equal to VQ, P equal to W by T, VQ by T, V into Q by T. Q by T is the rate of flow of charge, that is called current. And we can see here V into I. So that is nothing but P equal to VI. So V equal to IR, that is nothing but of Ohm's law. V equal to IR, substitute the values. So the energy is given to the conductor, that is P into T, VI into T. So H equal to IR into IT, that is nothing but H equal to I square RT. H equal to I square RT. H equal to I square RT. Each and every line is a diamond. Each and every line is a valuable point, expensive point. If you neglect each and every line, if you neglect any line, you will lose in exam some marks. Maybe problem may come from this. Problem may come from this concept. So now you see, so potential difference equal to potential difference equal to potential difference equal to potential difference equal to W by Q. W equal to VQ, I equal to Q by T. Rate of flow of charge is called electric current. Yes or no? Whatever I given the introduction for this concept, is it reliable? Is it worthy? Yes, it is worthy. So W equal to VQ. So P equal to W by T. So rate of flow of charge W equal to VQ. So this one I am substituting. Then you will get it. So in the place of VQ, VQ by T, Q by T is I. So PI, P equal to VI equal to P into T. So VI, so T. This is also known as Joule's law of heating. This is also known as Joule's law of heating. So this enough. This is and so one more topic is there. One more topic is the last topic that is about heating effect of electric current. Sir, these are too many memories. You know one thread. So you want to climb, you want to cross the river. Okay, so one side it is in our hand, thread. Another side is okay, it is tied to the tree. So river is 100% is river. A river is there. So if you hold the thread, so one by one, if you move forward, even river is there, so you can cross the. So even water is there in the river, still we can cross. How? You hold a thread, so you can reach the destination. Here also same thing. It is a chain. It is a chain link. So it is a chain link. So you can see V equal to W by Q. So from this W equal to VQ. So cross multiply. We know rate of doing work, power. So VQ in the place of W, VQ. So we know I equal to Q by T. So I equal to Q by T. So VI. That is nothing but P equal to VI. So whatever the energy is given, that is equal to P into T. So in the place of P, you substitute VI. In the place of V, from Ohm's law, V equal to IR. Then you will get the formula H equal to I square RT. Okay, so no problem. Don't worry. Still, you can what we can say. Watch many times. Same video, watch many times. Many times, if you watch, you can get it. You can check my previous videos also. You can check. Okay, done. So you can go to playlist. If you want to watch videos, you can go to playlist and see the live class and playlist. there are plenty of videos I may no I so live classes only I uploaded. So I uploaded anyway, it will upload after the live class, automatically it will upload. So you can check in the live. So go to the channel, so click on live and watch the videos. Even go to the playlist also, light reflection diffraction. These all live classes I am adding to the playlist of light reflection diffraction 2025 this year. Okay, so you can check that playlist no playlist. Okay, so you can get extraordinary videos, so quality content. Okay, effective content is there. You can go and check. So if you have any doubts, you can ask me. So now talk with Seva sir, you can join. Only we will talk general talks regarding the preparation process and the timetable. So everything, right? So thank you so much. Again, we'll take class tomorrow, 9 p.m. Even 6 p.m. also I'm taking class for a grade 11 and JEE NEET students. And anyway, it will be helpful for JEE NEET and grade 12 students. And 6 o'clock, 6 p.m. every day. 6 p.m. every day I'm taking for grade 11 students, all the topics, like units and measurements, scalars and vectors, motion in a straight line, motion in a plane, gravitation. So like that, thermal properties of matter, thermal properties of solids, liquids and gases. Okay, thermodynamics. Like that's all the topics I'm discussing. So join everyone. So inform your seniors, those who are there in our so like nearby and knows. So then you can ask them to join to 6 p.m. You can get we can discuss, and 9 p.m. it will continue. So it will continue. So check it once. Still, if you have any discussion, any classes, if you want, still after that also, still if you want any discussion, any classes you want, so you can contact this number. So this is your Siva sir signing off. Thank you so much. This is from Student Brand signing off. Namaste.